Hello, and welcome to this webinar on PLM data migration strategies. My name is Mark Young and with XLM Solutions. Quick overview of XLM Solutions. We at XLM Solutions are a complete PLM solution provider. We've been in business since 2005 and bring many years of experience within the PLM and digital transformation industry. We really pride ourselves being highly respected in the PLM industry for both our business and technical expertise. Not only do we follow and implement and instruct our customers on PLM business best practices, but we keep ourselves up to date on the latest technologies out there around PLM and computing in general. We are a Dassault business partner, a partner of SolidWorks, which is a subsidiary of Dassault Systems, and also a Eris partner. So we really have a broad spectrum of different PLM and PDM systems that we provide expertise on. We really dedicate, it's been a company's mission from day one to really dedicate ourselves to quality and excellence. We're always staying up to date on the latest technologies, doing new research on best practices, understanding what the industry trends are, etc. So we always are on the cutting edge of what's coming out, but also bring a good base of 20 years of experience of what works and what does not work. And we provide all aspects of PLM, PDM implementations, everything from discovery workshops to general implementations, performing customizations, integrations to other systems like ERP systems, data migrations, which we're talking about today, and training and support. So let's get into PLM data loading strategies. With any PLM data loading project, and usually companies are going from system X to system Y, migrating data into that new system can be a daunting task. There can be a lot of unknowns around it. But with diligent planning and thorough testing, the process can go smoothly. So here we'll talk about some strategies and some areas to look at to ease that pain and help you put in place a successful migration solution. So we'll talk about, we'll break this presentation into three main sections: pre-migration data analysis. We'll talk about data cleanup and process review, different data formats you may run into, different data rules that you want to set up when you're loading the data, and then costs and estimates of time to do such a migration. Talk about different data loading options that are out there and different technologies that can be used. And then finally, we'll talk about the execution of the migration, testing, verifying data, preparing for that final production data load, and then finally the production data load itself. So the first thing we do when we start a migration project, or even before we start the migration project, when sometimes we're just scoping out what will be involved in that migration, is we need to analyze the data to be loaded. And that can be broken down into various categories. We've broken it down into 4 here, but it really can depend on the situation at hand. But these are very common categories to look at when scoping out or analyzing what will be loaded. So the first one dealing with the legacy data in general. So where is that data coming from? Is it a file or folder-based system? So is it just a bunch of files on a network drive? Is it a bunch of files on a network drive and an Excel spreadsheet that has metadata associated to it? Are they coming from what I call legacy systems or a legacy PLM system? And in that case, usually there's a database and some type of file vault or file store behind it that stores the files. Could it be hard copy data? We still run into customers that have, filing cabinets of drawings that, are hard copied and need to be scanned and put into the system. So, you don't come across that very often nowadays, but that's still, a possibility. And then understanding the type of data that's going to be loaded. Is it CAD data? Usually with CAD data, there's links or relationships between the CAD files, between the parts and assemblies and drawings and models, etc. Is it flat data like Office files or other file formats? Is it just metadata or a combination of metadata and files? So really understanding what data you're dealing with. The next thing is, understanding how you can get access to that data or export it out, basically. So, if it's file folder based, it's pretty easy. It's on a network drive. If it's a legacy system, like a legacy PDM or PLM system, can you get access to that system? Can you get access to that database? Do you know how to read that database to get the data out? Is all the data in there, or could there be a situation where data is missing for one reason or another? It didn't get backed up properly, or certain projects were not put into it, etc. So making sure it's you have access to the data, and then sometimes you need to involve additional experts that have the proprietary knowledge on that system to help you get that data out, depending on what system it is. Then we talk about mapping rules. So how will the data from the legacy system get mapped to the new system being implemented? And a lot of times these rules are evolving rules. They'll change as the new system gets implemented and as the data migration goes on. But some high-level rules can be determined at this time. How will fields or properties get mapped from one system to the other? Do you have states or workflows in the various source and destination system, and how will those states get mapped over? Do the systems in question share the same revision sequences being used, or are they different, and how will they conform with each other? Are there I'm going to use the word classification of data, whether it's by class or type or item type between the systems, and how do those types of classifications get mapped over? Any special links or relationships that exist in one system, and can similar links and relationships exist in the new system? And then is there any other special logic, customizations that were written, or unique behaviors that need to be handled when moving the data from one system to the other? So this is probably the majority of the time spent analyzing the data to understand, what type of manipulation or work will need to be done. And then finally, usually you don't know how long it will take to migrate the data until you actually start testing it. But you should be able to have a good estimate based on the amount of data there is and where you need to migrate it to. So you can do a high-level estimate of how long that will take and what the downtime will be, and make high-level analysis whether this can be done over a weekend. It has to be split and be done over multiple weekends. It can be done during production time, etc. But to understand, that time frame you have to do the migration, and if it will be a long time frame, how to handle it to meet the end customer's requirements. So data cleanup. Everyone comes and says, oh, our data is clean and it should be a smooth migration. And every time, we do a migration project, we find that, yes, there are issues with data in one area or not, and time should be spent to help analyze the data, make sure the data is good and clean and expected, and clean up the data if necessary. Data cleanup could be a manual cleanup, or you could write, automations to automatically clean up the data based on specific rules. So what are some typical things we run into or we see, doing a data cleanup exercise? We run into, duplicate part numbers. We'll have different files or different objects, but they have the same part number. And do they truly represent, the same part number, or are they representing different data and they just got the same part number? Duplicate file names. We'll see the same file, washer one, that SLD PRT 3 times. And does that all represent the same washer, or are those actually different washers but share the same file name? Duplicate files with different names. So we might have take that same washer one example. Someone could create a washer one and then save it as washer two, washer three, and washer four, but it's all the same file underneath. And we can analyze that and determine if that's the case, and then figure out how to fix it. Which one do we want to use, and make sure the other ones point to that original name. Missing or incorrect file attributes. So usually, I'd say the 3 common attributes that we deal with are part number, revision, and description. So does each object we have or that we're going to migrate have a part number, revision, and description? And if they're missing that, how do we handle it? Missing or incorrect file association or links. Again, this is a lot of times dealing with CAD files, but are the assemblies pointing to the right parts or sub-assemblies? Are drawings pointing to the right models? Are files missing? Are links broken, etc.? This is making sure your file integrity of your CAD data or other data is valid. Dealing with revisions, the data being migrated, do the revisions follow the correct revision format required? Or was the customer allowed to put, type in user-defined revisions, and revision values are all over the place? So making sure revision data is good. And then dealing with, latest versus full history. Do we have assemblies pointing to non-latest parts, or latest parts used in non-latest assemblies? Making sure the integrity of the CAD structure, the BOM structure is correct to be loaded. And then finally, this goes back to incorrect file attributes, but in the destination system, are there attributes that are mandatory, but what gets mapped into it doesn't have a value? So any mandatory attributes in the destination system that doesn't have a source system value, should be detected and handled. So those are a lot of common scenarios we run into. There are utilities out there to analyze a lot of that data. We have various utilities that we run to analyze it, report, and even fix problematic data. So another thing to deal with or to understand is when you're migrating data from one system to the other, and maybe I even alluded to it, it's one thing to say, okay, I have the data in system X, and I want to get the data in system Y. Let's just map everything from system X to system Y and migrate the data. But really, you want to take a step back and understand that you're going from one system to another system for various reasons, and systems behave differently. So you don't want to necessarily recreate your your exact same work behaviors and environment in the new system as you have in the original system. You really want to do and work how the new system works best. So you really need to take a good understanding of how the new system works and understand key behaviors of it. So file access, how do users get access to files or get access to data? How does search work? Is it more based on searching based on a field, or more of a fuzzy Google-based search concept? Permissions, are there similar permission behaviors in the old system or new permission behaviors in the new system, and that may affect how data gets migrated. License implications. Maybe to access certain types of data, you need different licenses. So depending on what licenses you've purchased in the new system may impact where or how you migrate the data. You may want to migrate the data differently if certain licenses are purchased or certain licenses are not purchased. Understand how metadata works, how attributes and properties work. Maybe in the legacy system you only had text fields, but in the new system you can have different fields like pull downs or multiple reference to a class or reference to object fields. Understand how workflows and states work. So you really want to have a good understanding how the new system works to best define how data will get mapped and behave in the new system and how you want to migrate the data over. In conjunction of that, when you're migrating to a new system or you're implementing a new system, like I said, you don't just want to reinvent the same processes, the same work behaviors in the new system as you had in the old system. Really, it's a good time to review business processes in general and revamp or update them based on how you're working today, not necessarily how you were working when you implemented the existing system. And based on those new business processes, it may change how you migrate the data. So a migration project is a great opportunity to evaluate and update the user experiences and how users work. And it may change how you migrate the data. You may say, hey, we have 5 fields in the legacy system, but we really only need 1 field in the new system. So we want to change our business rules, change our logic to concatenate all those 5 fields from the legacy system and put them in that new field in the new system. And as this process review and update, usually probably happens primarily at the beginning of any PLM implementation project, PLM migration project. It's something that goes or happens throughout the project, because as you progress in your implementation, new behaviors of the system, new requirements may become apparent, and you're going to go back and reevaluate and tweak the system as you move along. But the key thing is any changes you make to the data model, to the new system, will affect the migration process. So, if you do make a change, you add more fields, you add a different type, set up different states or workflows, it very well may impact the migration process, and you need to be aware of that. So usually migrations happen in 2 parts. There's a extract from the legacy system and a import into the new system. So talk about extraction first and then import. But whoever's doing that extraction should really have some familiarity with the legacy system. They should know, how it works, how data is stored, how to get data out. And a lot of times in migration projects, there's 2 parties involved. There's the party that knows the legacy system, and then the party that knows the destination or the new PLM system. In many cases, it's the same company, but in a lot of cases, it could be more than one company as well. Most legacy systems, databases can be reversed engineered. So even if you're not an expert in it, you may say, I feel comfortable enough, reverse engineering it to get to the data. So, that would be a question for the implementer, whether they, again, feel comfortable with the legacy system, or they need to bring in another expert to get that data out. When you are extracting the data, you want to obviously extract the properties, the metadata, links and relationships between objects. Obviously, very important for CAD data. Deal with extracting full history, maintaining the revision sequences, and any other object data that needs to be migrated or extracted. And just again, an overview. We have expertise in a lot of systems that we've migrated out of or migrated to. So deal a lot with Innovia Smart Team, Innovia Matrix 1, which is now morphed into 3D Experience, DBWorks, Autodesk Vault, SolidWorks PDM, Meridian, Microsoft SharePoint, Aris, and more. So we have a lot of experience in various systems for conducting these migration projects. So when you're extracting the data, like I said, usually we extract the data, and there's two ways that probably data can be extracted depending on the scenario. So one is we extract the data into what I would say is a neutral file format. A lot of times we use XML as that format, but it's in a neutral format that the other system can read. They'll probably have to translate it to some extent, but it is in that neutral format that another system could read and translate. The other option is we can extract it directly to a format that the legacy PLM system can use. So for example, if we're migrating into 3D Experience platform, it uses, or there's a tool called XPDM that is used to import data. So we can extract the data directly into that XPDM format to be imported into 3D Experience. If we're using SolidWorks PDM, there is also an XML format that the SolidWorks PDM import tool uses. So we can extract data directly to that format. Or Aris, for example, it has an import tool that it likes to read delimited data, flat delimited data. So again, we can extract the data out to a delimited format to be imported through the Aris tool. So depending on the system, we can extract it to a neutral format, but it would most likely need to be manipulated on the import side or directly to a format that a lot of systems can directly import. And then a lot of times during the extraction process, you're going to not only extract it, but transform the data as well. And examples of transforming the data, the legacy system was managing revisions in an alpha format, and the destination system now is going to manage revisions in a numeric format. So we can translate an alpha, A becomes a 1, B becomes a 2, C becomes a 3, all the way up to AA, which would be 27, etc. Whatever. So we can transform the data into a new format based on some rules. Another example is merging TIFF files. So we had a scenario where each sheet of a drawing had its own TIFF file, a separate TIFF file. And when they migrated into the new system, instead of having a separate object for each sheet of a drawing, they said, let's merge all those TIFF files that represent one single drawing into one combined TIFF file, and then just migrate that data as one file or one object into the destination system. So we took multiple files that were merged and then migrated as one object into the new system. And might seem straightforward, but it's interesting because when you're merging the files, not only do you need to work with merging the files, making sure they get merged in the correct order, but metadata. What metadata do you take? If you have different metadata on different drawing sheets that are going to become one drawing, which one works, or how do you handle different metadata? So there can be a lot of rules and logic that goes into the transforming of data. Or it could be very simple, like alpha revisions to numeric revisions. Importing data to PLM. So I list different ways that data can be imported into PLM. And we start off with what I always say is manual. For small sets of data, sometimes it's easier just to simply open that data up in and save it, manually save it into the new PLM system. So, it's good for small sets of data. If you're doing CAD data, and let's say you have a one root level assembly, for one product, and it contains 100 parts maybe. It may be easier just to open up that root file and save it directly into the new PLM system. So again, it's good for small sets of data, probably not appropriate for large sets of data because engineers' time is available and you don't want them just spending time entering data into a new system. Also, manual method probably is not great at handling revision history if you want to load full revision history of data as well. Next is many vendors out there, at least vendors for key PLM systems, have their own proprietary tools for importing data. Usually these tools aren't, magic buttons that, oh, I have this tool from the vendor, I can just load all the data. Usually there's still work involved. As I mentioned, data cleanup, mappings, etc. But they have tools to help get the data into their PLM system. And they're good because usually they're QA'd by the vendor themselves and supported by the vendor. So if something goes wrong and they don't behave properly, you can go back to the vendor and say, why isn't your import tool working as designed? And they will or should support it. At the same time, some of the vendors' import tools aren't generic enough to meet specific client or customer needs. So they may not have the flexibility in the tools to handle every unique condition an end customer may need. And then, I say there's direct database updates. Again, most PLM systems run on a database, and it's possible to write data directly to the database itself and bypassing any tool or middleware or whatnot. In that case, direct database updates are very fast. You can load, millions of records within hours. They're very fast, but you really need to understand the database structure that you're importing the data to, understand how that database structure works, how any internal fields that may get set work, relationships between tables, etc. So you really need to really understand the underlying database structure, and you're really doing this at your own risk. If you load data, usually vendors don't support loading data directly to the database. So if you do that, and you make a mistake or you load the wrong data and now your data is corrupted, or you go do an upgrade and you can't upgrade because you have corrupted data, it's really at your own risk. So, with direct database updates, the pro is it can be very, very fast, especially when dealing with, hundreds of thousands, millions of records. But the con is, you really need to have a good understanding of that database structure and, make sure you're setting the tables and the fields correctly as if they were set, if you're creating that data by hand. And then finally, there's custom tools. For example, we have various different custom tools or create our own custom tools for migrating data. And really, when we can create or use our tools, they really can support any requirement regarding migrations, special cleanup rules, special transformation rules, special rules that check for errors or invalid, logic scenarios between relationships of the data and report against it. So really we can handle any requirement, but sometimes, to develop a custom import tool, it may take longer to develop. You need to test it more, etc. So, again, the pro is it can really handle any scenario under the sun, but sometimes it may be more involved or costly to do that approach. And then in a lot of cases, it's a combination of everything listed here. It may be a little bit of a custom tool, maybe a lot of a vendor import, maybe some manual data entry for very one-off situations, and Maybe in some situations you do some direct database updates. So there's nothing wrong. There's not, one scenario is always the case, and a lot of times it's a combination of technologies and tools to use to make that migration project successful. When migrating data, some things to consider. Kind of as mentioned, there's going to be different data models between the legacy system and the new PLM system. So, really understand that and understand how the two systems behave and work differently, and make sure you're comfortable with your good understanding of the new PLM system to come up with the best data migration plan. Any migration projects, you want to allow yourself or the end customer to grow with the new PLM functionality. So you never want to migrate data into a corner where it can't be expanded, meaning, oh, we migrated the data this way and now we can't use this new functionality, or we can't do an upgrade, or we can't expand the system. So any data that gets migrated should look in the system as if it were created through the new system. It shouldn't look differently. So if you go into the user interface to create a new object, that is how the data should look if it gets migrated per any of the tools I mentioned. Making sure the internal fields get set correctly, etc. When dealing with large migrations, obviously, any migration, needs to be done over a reasonable time frame. A lot of times they're done over a weekend. Sometimes they have to be done less than a weekend when dealing with national companies in different time frames. That weekend time frame may get shortened, if you're dealing with Asia, North America, Europe, etc. When we're doing migrations, we always recommend to do a single migration, what we say is a big bang, and really where we can do, the full migration over a single weekend or a single time period. In that case, we, shut down the legacy system, do the migration, and then everyone starts working in the new system. But sometimes that can't be done. There's just too much data, the systems aren't fast enough, etc. And in that case, we look into doing delta migrations. So, delta migrations would be you start the migration and let it run over, a week, multiple weeks, etc., while the users still use the legacy system. And then over a weekend, you would only migrate the deltas, what wasn't migrated originally, which is usually a much smaller data set over that weekend, and then allow the users to use the new system. However, delta migrations can be more expensive. There's more to test, more to make sure the deltas get handled to get migrated properly, etc. So we say only do delta migrations if it's absolutely necessary. And then other things to consider to speed up migrations is actually the hardware itself. SSD drives for the database, increasing the memory, having multiple drives for better input output, etc. can also have a great impact on migration performance. Some general migration methodologies and best practices. As I've again been alluding to, install and test the out-of-the-box new PLM system. Make sure you really understand how it works, how it's intended to work out of the box, to get a good understanding of how you want your legacy data to behave and work and get mapped to that new system. Do your due diligence. Obviously, review the legacy system for what you have. Identify data to migrate, map and reorganize the data if necessary, address any concerns, and then build your cutover plan and working process for that migration. Obviously, you're going to want to have a test environment in place to test the migration. So make sure when again scoping out the project that there is a test environment to be used for the migration, and that test environment can be refreshed because you'll do a migration and then you'll want to refresh it and remigrate. Based on your migration requirements, you'll work with a partner hopefully, or yourself, to pick the best technology out there, or develop your migration solutions. Obviously, you're going to want to run various test cycles to make sure that the data can get migrated successfully, and understand the time it will take to migrate the data. Validate the data, and we say only you can validate the data, meaning the end customer should play an integral role in validating the data and making sure it's working as they expect it to work. Plan the production rollout, set user expectations, and run the production migration. So, with any migration project, there's always a balance between cost, time, resources involved, etc. And sometimes it doesn't make sense to automate everything. Sometimes it makes sense to automate some parts and manually load data other parts. Sometimes it makes sense to invest in a very automated tool that's going to do all the transformation, and sometimes it can be done more by hand. So really, again, working with the end customer, or to understand the requirements, the budget, the time frames, the resources available, etc., to balance out what will be that best solution and most optimal for this migration project. With testing the migration, again, this is extremely key part of the migration project. Very, very important to test migration. No migration is ever done correctly the first time, so you're going to run into issues. You may find missing data, bad links don't get created correctly, the revision scheme wasn't consistent and couldn't get imported correctly. You might have bad mapping rules where you're trying to load a character data into integer fields, or vice versa, etc. So you're going to find issues and you need to clean it up. Again, whether it's manual cleanup, changing your data loading rules, or modifying the PLM system. Maybe if you have that scenario where you're trying to migrate character data into an integer field, maybe you're going to say, listen, let's not make it a integer field anymore, let's make it a character field. Or let's go back and look at our legacy data, and where we have characters in this field, let's scrub that data and remove those characters. So depending on what didn't work will depend on how to best fix the situation. You may have bugs. If you have a custom migration code, there may be bugs or issues with that tool that needs to be fixed for another migration. Or maybe you have data loading procedural rules. So, for example, a lot of systems have fields like created by, modified by, etc. And if the users aren't already in the system, you can't set those fields appropriately. So it may be a simple procedure where it says, first we need to load the users, then we can load data that may reference that user information. Document your procedures, make changes as necessary. If possible, if you're doing manual work, and sometimes it makes sense to do manual cleanup, but I say automate if possible, because you may forget to do it each test cycle. So if you can automate it, you don't have to remember to do it manually. And when you do things manually, it can be prone to mistakes as well. So automate where possible, and then test again. Like I said, you'll most likely want to go through multiple test cycles until you obviously feel comfortable with your test migration, or with your migration process as a whole. Pre-data loading planning. So this is probably it should be pre-production data loading planning, but when you feel like you're getting ready, you have some very successful test migrations, you now want to plan for that production migration. So when will that legacy system be turned off? Let's put a date on the calendar to actually do the production migration. Now you should have a good or a good estimate of how long it will take, so you'll know what that downtime needs to be. And can it occur during non-business hours? Could it be done in an evening? Do we need it to do it over a weekend? a long weekend, a Christmas holiday, etc. Make sure you specify the data loading process. So what are any required pre-data loading activities or events? It may be as simple as sending out an email that the system is going down, turning the legacy system into read-only. Maybe you have to copy some data over from the legacy network to the new production network. But make sure all those activities are documented, and your data loading procedures are documented. Make sure you identify key personnel for the various parts of the data loading process. Who at the company, who at the partner, the system integrator needs to be involved within the migration, and make sure there's a contact list available to make sure everyone can get a hold of each other if something happens. So the final data load. We always say with proper planning and testing, the final data load should go smoothly. Make sure to follow your documented procedures, but allow buffer time for unexpected issues. There's always Murphy's Law. There's always something at the last second that might have been changed or wasn't accounted for, and make sure you have a little bit of time in there to handle it. And then finally, be prepared to support the new users in the new system. We didn't talk about that too much because this is more on data migrations, but with any new system, there's always going to be a learning curve for the new users. The system may not be fully functional or vetted, so make sure you have good support in place to support those users using the new system. And should be as easily as a push button at this time. And then in conclusion, as we said, with proper planning and testing, migrating data to any PLM system should go smoothly. Make sure to pick the best migration tools and partner based on your needs and your budget. Follow your documented procedures, allocated buffer time for any new issues, and prepare to support the users in the new system as mentioned. The devil's always in the details. With any migration project, some people may say it's easy. Just puts data in system A into system B, but there's always many different details that go along with it. So make sure to fully understand the requirements, the data sets you're dealing with, limitations, and technologies being used, and most importantly, set the right expectations, with any migration. We'll say, we're not afraid to admit it, no migration is usually 100% perfect. Whether it's bad data, system issue, whatever, no system is 100% or migration perfect, but there's nothing wrong with, striving for that 99.99% success rate. So, you obviously need to make sure it's good that users can use it. And really, anything's possible. Most migration scenarios can be accomplished in a relatively straightforward manner. There has yet to be a migration project that we could not accomplish. So, if there's a will, there's a way to make it happen. And with that, I will open it up to any questions that anyone may have. So the first question is, how long does a data migration project take? And again, that really depends on what system you're coming from, what system you're going to, what are your data rolling rules, how much data you're dealing with. But typically, I'd say a migration project is usually 3 to 4 months in calendar time, from complete start to complete finish, but probably around 10 to 15 days of actually billable time that we're doing the work. So that's a very rough estimate based on averages, but sometimes migrations can be done in a week. Sometimes it could take a year. It really depends on the situation and different factors that are involved. Next question is, can you translate CAD data when you do migration projects? So yes, we're not CAD translator experts, but there are tools and technologies that we can tie into to translate CAD data from one format to another. I don't know if I'd always tie that into a bigger migration project. Maybe I'd break that into 2 migration projects, maybe one where you migrate the data and then another one where you translate it to another system. But those scenarios can be done, but definitely they add complexity to the migration. Another thing we've done, which is sort of similar, is we've actually performed upgrades on the CAD as we migrated it. So if you can imagine, different, take SolidWorks or Inventor, you've been using it for 10 years, and a file that was created 10 years ago in SolidWorks 2010 that hasn't been touched, we could upgrade that to the latest version of SolidWorks as we migrate. So, or different CAD systems. So that's something else that can be done through a migration project. That looks like all the questions for now, but if anyone has any follow-up questions or comments, I would love to hear from you. As I said, here is my contact information, so please reach out to me if you have any comments, questions, suggestions, etc. But with that, have a great day, and thank you for attending this webinar.